All right, so we are going to be doing very similar work, but we're going to use different language or verbiage. All right, so we have here the matrix A and the vector X and B. So A, X, B. So we say that the multiplication by the matrix A transforms X into B. So that's where the word transformation comes from. So the ax equal b equation here takes the vectors x, this one here, in this example here is in R4, and it transforms it into the vector b that's in R2. So I'm gonna make a picture here. So here is R4, and this vector x here gets transformed into this vector b that's in R2. And the method of transformation is multiplying by the matrix A. So that's what we want to think of. All right. So in general, we have the transformation from Rn to Rm, and A will be an m by n matrix. So notice the difference here. So m is this one, right? And n is this one. So in this case, I have a 2 by 4 matrix A, right? And so here I'm going to have an m by n matrix. Okay, so it takes everything in Rn, that's in the domain, and goes to Rm, and we're going to call that the codomain. And then this transformation, T of x, is the same thing as saying multiply by the matrix x. So here we have it. So we're going to define this transformation of x as Ax, where this is the matrix A, and we want to find the x's that get to this B. So remember, the x's are here in the domain, and then we're going to be taking and doing matrix multiplication to get to the vector B. So you can see this B is in R3, and I see that this is A is a 3 by 3 matrix, so this must be in R3 as well, right? Because it's domain to codomain. All right, so I'm looking at A being a 3 by 3 matrix. So find the x that goes to B. So what that is asking us to do is solve the augmented matrix. So if I put the augmented matrix together, -3, 1, 6, 3, 2, -2, 1, -1. Okay, so I put this in my calculator, and I got this as an answer. All right, so what does this mean? This last row here says x3 is -3, x2 is -12, x1 is -11. So my x vector is -11, -12, -3. And is this a unique solution? Yes. Right, because I have one value or one vector x that goes to that vector b. All right, sometimes we're going to have infinitely many solutions, and we'll see that shortly. All right, here we go. So here I have my transformation defined as multiplying by this matrix x, or matrix A. So now find the x that goes to this b. Okay, so here I have domain multiplying by matrix A, getting to this vector B, right, this column vector, which is in R2, and I can see that A is a 2 by 3 matrix, right? So this vector that's in the domain must be in R3. All right, that's what I'm going to end up solving for. Okay, so let's put together our augmented matrix, because I'm solving for the x's. I'm looking for the x that goes specifically to this b. All right, so I put it in my calculator and let them do the row operations for me. So I got, go away, or it's not going to go away, 1 0 3 3 0 1 2 1. Okay, so then from here, I'm going to see what solutions, right? This row here says 1 times x1 plus 3 times x3 equal 3. The second row here says 1 times x2 plus 2 times x3 equal 1. Okay, so now remember, these are my pivot positions, so these are my basic variables that I want to solve for. So I want to solve for those two. So I get x1 is equal to 3 minus 3x sub 3, and x sub 2 is equal to 1 minus 2x sub 3. All right, so from here, I have my, and then I know, what do I know about x sub 3? X sub 3 is my free variable. Okay, so this is the parametric way of writing the solution, or we can go a little further. Remember, we talked about this before. I could say x, which is x1, x2, x3. I'm going to encourage you to write this step down because this will help you. So what is x1 equal to? 3 minus 3x3. What is x2 equal to? 1 minus 2x3, and x3 is itself. So I could break this up. Remember, I could say that this is, I could factor out the terms that have the no x3s in it. So that would be the numbers 3, 1, and 0. And then I would add on those that have the parameter x3 in it. So that would be -3, -2, and 1. So this is the parametric description of the solution. Since I see I have a free variable, I know that it is not unique. And I know that there are infinitely many solutions. All right, moving on. So here I have a 2 by 3 matrix. I think it's the same one. Yes, it is. And there, here I'm giving you the x. So again, I'm drawing pictures so that you keep in mind what you're doing. So I'm coming from the domain, and x is in the domain, right? So here's x. The transformation is multiplying by a. So this one is asking me to find the image of x, and that's going to be the b. So how do I do that? Well, the transformation is take the matrix A and multiply it times x, and I do, and I get 5, -15. Is this unique? Yes. Yes, this is unique. There's only one answer, right? So this only goes to one solution. So it's always going to be unique. Taking one x and multiplying it by a, it's going to be the same thing every single time. There we go. All right, so let's look at this next one here. So I want to find all the x's in R4, in the domain, right? All the x's that are in the domain that go to the 0 vector. So the 0 vector will be in the codomain, right? The codomain is everywhere you could possibly go to, so the 0 vector is actually in the range because we say we're going there. So the range is all that are reached, right? All that are reached by AX. Okay, so here I've got my domain, which is all of R4. Those are my x's, and I'm using my matrix multiplication of A, and I'm going to my codomain, and because I see that the size of this is 3 by 4, I know this is R3, so I'm looking for all of the vectors x that go to the 0 vector. So there can be more than one, right? So there can be this different value that goes here, and then this other vector that goes to 0. So there can be more than one vector that goes to the 0 vector. So goes to the 0 vector. And we know for sure, I know of one absolutely, right? So this one here, right, I could call, what letter do I want to use? We'll just use x sub 1, right? And then this one here, I could call x sub 2, so there'll be different vectors, right? But I know for sure this vector here, which is the 0 vector, will always go to 0 because this is the trivial solution, right? Because when I'm looking for the things that go to the 0 vector, I'm looking for the solutions of AX equals 0. All right, Now I'm going a little long here. I'll finish up in a second. So here we go. So I'm setting up the augmented matrix. 1, -3, 5, -5, 0, 0, 1, -3, 5, 0. Oops, 2, -4, 4, -4, 0. Okay, so in your calculator, reduced echelon, 0, 0, 0, 1, -3, 0, 0, 0, 0, 0, 1, 0. Okay, so from this, you pause and see if you can get the correct solutions out of here. What do these rows mean? Okay, so this first row means x sub 1 minus 4x sub 3 equals 0. The second row here means x sub 2 minus 3x sub 3 equals 0. And the last row means x sub 4 equals 0. Okay, crucial step. Write out x1, x2, x3, x4. Write out all of those so then you can start substituting in what you know. Remember, you're solving for your basic variables. So I'm going to skip the step of writing it and just put it in. So x sub 1 is equal to 4x sub 3. X sub 2 is equal to 3x sub 3. X sub 3 is equal to itself, and x sub 4 is equal to 0. So factor out the x sub 3, and I get 4, 3, 1, 0. So this is not unique solution. There are infinitely many, since there is a free variable. Free variable exists.